soldier! This is Drill Sergeant Reid, and I'm back! So get your bed made, get your shoes signed. Time for you to get in line, soldier. 10 hut and suck in that gut, because today we're ready to get into EOG Fruit Camp Day number 5. Today's topic is equations and inequalities, so we're going to be reviewing some things today and how to get those things solved and how to get those arrows pointed in the right direction, because you don't want them pointing in the wrong direction, otherwise you're going to be shading them in the wrong direction, and we don't want any of that. So let's get everything lined up, straightened up, and let's carry on today. Strap up those boots, folks. We're getting ready to go on a major hike, so here we go. All right, today you need to make sure you've got your page out that says equations and inequalities, and we've got some things to remember. So let's start out there. Always want to be ready, just like the Coast Guard. Here we go. So equations, of course, the whole objective here, folks, when you do an equation, your end game or your goal is to try and get the variable isolated. We're going to put that variable in solitary confinement. Now, isolated can also mean you want to get the variable by itself. All right? So you want it to say x equals something, or y equals something, or n equals something. So there's 3 important things to try to remember, and we're going to be doing these here down in our examples that we're getting ready to do in just a second. One of the things I taught you folks earlier in the year is to separate it into 2 sides by using the old train track method, and we'll be reviewing that here in just a minute, the old train track method. Remember, whatever you do on one side of the tracks, you got to do the same thing on the other side of the tracks to keep your equation balanced. All right, so if you do it on the left side, you got to do it on the right side. Okay. Second thing is, make sure you remember that we're using inverse operations. Inverse operations. So inverse operations means, of course, if it's got adding, we're going to use subtracting to cancel it out, or if it's got subtracting, we're going to do adding to cancel it out. If it's got multiplying, we're going to use divide to cancel it out. If it's got dividing, we're going to use multiply to cancel it out. So inverse operations there. Third thing is, I want you to remember that we want to cancel out the constant first. Cancel out the constant first. So again, from our last lesson, we know that the constant is the plain old regular number. All right, so wherever that happens to be, sometimes it's at the front, sometimes it's in the middle, wherever that's at, you always want to try to cancel it from there. All right, so
there's 3 helpful hints to try to get your things back in order here. So order is always important, so let's go through and work some of these and make sure we know what we're doing. So let's take this box right here and let's divide it into 3 parts. Uno, dos, and tres. Let me get it slid up here. I need to pull my camera up just a hair. And actually, I'll put it down closer on that one. Okay, now let's try this one first. Let's say we've got negative 6x minus 14 equals negative 62. Okay? So, let's say we, of course, are going to have to cancel out the constant first, which, of course, would be the negative 14 right there. So we're going to add 14 to both sides. If you want to use the train track method, I'm going to go ahead and draw those in there. So if I add 14 on the left side of the tracks, that means I need to add 14 on the right side of the tracks. The 14's over here, of course, make a 0 pair, so they cancel out. Okay, we're canceling that out, canceling out the constant first. Negative 62 plus 14. Now that takes us back to our earlier lesson. These have got different signs, so we're actually going to subtract them and take the sign of the bigger number. So, of course, the bigger number is 62, so that's going to definitely be a negative. And then 62 minus 14 puts me at, let's see, that's 12 plus 8. That's going to be negative 48, okay? So negative 48 equals, and I'm just going to bring down the negative 6x. All right, so at the moment, I've got negative 6x equals negative 48. That, of course, is multiplying, and I want to cancel out the multiplying with dividing, so I'm going to divide each side by negative 6. Of course, negative 6 divided by negative 6 right there, that cancels out to a 1. Don't tell me it's 0, you ding-a-ling. Negative 6 divided by negative 6 is 1. Negative 48 divided by negative 6. Now, what's a negative divided by a negative, soldier? A negative divided by a negative is a positive. What's 48 divided by 6? That would be a positive
8. So there is your answer to that equation, okay? X would equal positive 8. Again, we've got the variable isolated over there on the left side, and we've got it equal to some number. So that's how you want to do it. We're going to use the train track method, use those inverse operations. Let's do one that's got
a little fraction in it. 2/3 x plus 6 equals 18. I'll scoot that over so you can see it a little bit better. Let's do this one. 2/3 x plus 6 equals 18. All right. So again, let's put our train tracks down. First thing we want to get rid of is the constant. So what out of this, the part that the constant, of course, the constant is that plus 6 right there. The opposite of plus 6, the inverse of that would be a negative 6. So we're going to do minus 6 on both sides. 6 minus 6, of course, is 0. So we've canceled that out. And then 18 minus 6, that's easy enough. That's just 12. So I got 12 equals, and then I'm going to trot this down here. 2/3 x. Now, the key to canceling out a fraction like that is to multiply by the reciprocal, okay? So we're going to multiply by the reciprocal. That is correct terminologies. It's always good to know the correct terminology, you scum sucker. So, let's take 2/3. The reciprocal of that, of course, would be 3/2. So that means I'm going to come over here and multiply by 3/2. 2 times 3, of course, is 6, and 2 times 3 there is 6. So 6 divided by 6 is 1. So you can cancel that out, right? 3 cancels out to 3, 2 cancels out to 2, and that cancels everything out to a 1, which is what you want, okay? So over here now we've just got the x. Now, 12 is a whole number, so you can put it over 1. 12 times 3 is 36. 1 times 2 is 2. And then, of course, if we just do 36 divided by 2, that'll give us our answer for x. And 36 divided by 2 is 18. So now I have accomplished the goal. I've canceled out everything by using inverse operations, and I've got the variable by itself. And I now know that x equals 18. The key to the whole thing is this part right here, though. You've got to make sure you multiply by the reciprocal. So just take that fraction, flip it over, and that, of course, cancels out over here. 12 times 3 was 36. 1 times 2 is 2. And then 36 divided by 2 is 18. All right, let's get to one of those that was like on the check-in that was a little bit harder. These are the ones I'm really worried about. Let's say we've got this, okay? Going to do all kinds of stuff in this problem. Going to put a lot of things together right here. All right, in the numerator, we're going to have a distributive property problem. And that is going to be divided by 8. We're going to set that equal to 6. All right, so the EOG people, they really like problems like this, so I'm going to make sure I take my time and really explain this one to you because I want you to understand how this works, okay? So down here, we want to get rid of that 8 that's in the denominator, okay? To get rid of that, again, we need to multiply by the reciprocal, and that would be 8/1, okay? And that means over here on this side, I've got to multiply by 8/1. If you want to go ahead and put your train tracks down, of course, that is definitely an okay with me. So 8 divided by 8, of course, cancels out. We cancel them out, and that gives us a 1, so that's gone. 6 times 8, of course, is 48. Now, I've got -4, and I've got to distribute that here in just a second. To x plus 4 equals 48. So the key to the whole thing right there, again, is what we talked about over here. We want to multiply by the reciprocal. So instead of dividing by 8, I just flip that over and multiply by 8/1. Now let's distribute -4 times x and -4 times 4. We talked about this in yesterday's lesson about distributive property and expressions, okay? So -4 times x is -4x, and -4 times 4 is -16. That is going to equal 48. So right there we use distributive property. And that should look familiar, okay? -4 times x is -4x. -4 times 4 is -16. -16 is now my constant. So I need to cancel that out first. What cancels out of -16?
that would be a positive 16. And I'm going to add 16 to both sides. All right, so now I've got negative 4x equals, that's 64. One more step and I'm home free. The opposite of multiply is divide, of course. I would divide by a negative on both sides. And now a 64 divided by negative 4. Of course, a positive divided by negative is a negative. And that'll go in there one time. That'll be 24 left, so that would be negative 16. I have now accomplished the goal of getting everything canceled out and getting my variable isolated. So x equals negative 16. Key to the whole thing is you got to multiply by the reciprocal here, then do distributive property, cancel out your constant, and then divide by negative 4 on both sides. So that's how that works for those. Hopefully you're following along with me, soldier, and I'm not leaving you behind. All right, got a few things to talk about on inequalities down here, and then we'll be done for today. So we got to zip through this. Inequalities. All right, just want to remind you there's a couple of things about inequalities. We've got less than and greater than, and they, of course, get the plain old open circles on the graph. All right, so they get those. And then, of course, we've got less than or equal to and greater than or equal to, and those are the ones that get closed circles on the graph. So when you graph it, it's going to have that. So the thing you need to remember is the new thing that we learned once we got down here is that if you multiply or divide by a negative, switch the symbol. So switch the symbol if you multiply or divide by a negative. Pull that up a little bit. Switch the symbol if you multiply or divide by a negative. Alright, so we're going to switch the symbol if we multiply or divide by a negative. Alright, so let's try a couple of these real fast. Let's say we've got 3 little problems down here. I'm going to try to do them 1 minute each, and we'll see how fast we can fly through these. So I got 4 minus 3k is less than or equal to 19. Okay, same as we did above, we want to get rid of the constant first. The constant, of course, is 4, so I'm going to minus 4 on both sides. Those are 0 pair. That means I've got negative 3k is less than or equal to 15, because 19 minus 4 is 15. Now, of course, I got to divide by negative 3 on both sides. Negative divided by negative cancels out there. Did I divide by negative in this problem? The answer to that is yes, so I need to switch the symbol to greater than or equal to, and 15 divided by negative 3 is negative 5. You always want to try to get the variable on the left, okay? Always try to get the variable on the left. That makes the graphing easier. So that one, of course, would be a closed-in circle because it's greater than or equal to. It would be shaded in going this way, which would be to the right because the greater numbers would be to the right. These are the true answers. That would be negative 5. Negative 4, negative 3, negative 2, negative 1, so forth and so on. All right, so that would be what the graph for that one would look like. All right, let's try one more. Let's say on this one we've got to do some distributive property. Kind of putting all this stuff together, aren't we? All right, so now I've got to do negative 2 times n and negative 2 times 3. So negative 2 times n is negative 2n. Negative 2 times 3 is negative 6. And that's less than negative 14. Want to get rid of my constant again first. So I'm going to add 6 there, add 6 there. Okay, so that gives me negative 2n is less than negative 8. When I add those together, remember you want to actually subtract them, keep the sign of the bigger number. And now I'm going to divide by negative 2. Well, am I dividing by negative in this problem? I am. So again on this one I got to switch. And that would be n is greater than a negative divided by a negative is a positive, so that's positive 4. So n is greater than positive 4. That would be an open circle because it's just a plain old greater than, and that still be going that direction because the greater than numbers would be that way. So that would be like 4, 5, 6, 7, 8, so forth and so on. All right. Final questions real fast here. We got one that's going to have backwards. We're going to do it this way. So let's say we've got 5 is greater than or equal to m divided by 2 plus 9. Okay? So
on these problems, we'll talk about it when we get down to the bottom, but you want to swing it around and put, that's my constant, okay?
Want to get rid of the constant first. 5 minus 9 gives me negative 4 is greater than or equal to m divided by 2. Just like we talked about earlier, you want to multiply by the reciprocal to cancel that out. So I'm going to multiply by 2 over 1. Am I multiplying both sides by a negative right there? I am not. Okay, so I don't need to switch the symbol at the moment. 2 times negative 4. I don't like it being that way. I want you to put the variable on the left like we did on these two. So just take that whole thing right there and swing it around to m is less than or equal to negative 8. Again, since it's got the equal to underneath it, that's going to be a closed-in circle. Shaded to the left because that's less than, so the less than answers are going to the left. That would be negative 8, negative 9, negative 10, negative 11, so forth and so on. All right. Soldiers, I hope you kept up with that. I hope you're doing all right. We're about halfway through this boot camp review, so if you can make it through the next few days, you'll be a full-fledged soldier. Because you're going to be ready for battle. You're going to be able to beat those EOG questions down and destroy that test. So just let me know if you got questions. We're done for today, so stay sharp. Continue to get that mind ready, keep that pencil ready, and keep marching forth to move up the ranks, soldier. Until next time, at ease and adios. This is Drill Sergeant Reid saying, have a great day and keep on marching.